Hey everyone! Welcome back to BugNoJutsu, where we dive deep into solving coding problems, algorithms, and everything in between. Today, we're going to solve a very interesting and commonly asked greedy algorithm plus heap problem from LeetCode called maximum number of events that can be attended. This problem looks simple at first glance but has a really smart solution that combines sorting, greedy strategy, and heaps all together. So stick around till the end because this video will not only help you solve this problem, but also sharpen your problem solving and algorithmic thinking for similar scheduling problems. Let's get started. Let's first understand what the problem is asking. We are given a list of events, and each event has a start day and an end day. The rule is simple. You can attend at most one event per day. Your goal is to attend as many events as possible. In simpler words, maximize the number of events you can attend while following the rules. Let's take a sample example to clearly understand this. Events equals 1, 2, 2, 3, 3, 4. Here's what these events represent. Event 1 starts on day 1 and ends on day 2. Event 2 starts on day 2 and ends on day 3. Event 3 starts on day 3 and ends on day 4. Now here's how we can attend the maximum events. Attend event 1 on day 1. Attend event 2 on day 2. Attend event 3 on day 3. In total, we attended all 3 events. This example looks simple, but the main challenge is how to solve this for large inputs where events overlap heavily or have complex schedules. Here's a quick suggestion for you whenever you face similar scheduling or interval problems. First, always try sorting the events, usually by start or end day. This makes it easier to process them in order. Second, think greedy. Try to pick events that end the earliest so you don't block yourself from attending future ones. Third, simulate the process day by day. Keep track of new events starting and prioritize the ones ending soonest. And finally, remember, heaps or priority queues are your best friend in such problems. They let you efficiently grab the event that needs immediate attention. This simple approach works like magic for many scheduling and timeline-based problems. Now, let's walk through how the efficient solution works without looking at code, just focusing on the core logic. First, we sort the events by their start day. This makes sure we process the earliest events first. Then we simulate the days one by one, starting from the first event's start day. Here's the key process we follow each day. First, we add all the events that start today or have already started, but not yet ended into a min heap. In this heap, we store their end days. The heap automatically keeps the event with the soonest end day at the top. Next, we attend the event that ends the earliest by removing it from the heap. This greedy choice ensures that we leave as much room as possible for future events. After attending an event, we move to the next day. Finally, we clean up the heap by removing any events that have already ended before today. They're no longer available. We repeat this process until there are no more events to attend and no more active events in the heap. This strategy ensures we maximize the number of events we can attend by always making the optimal greedy choice, attending the earliest ending available event each day. Now, let's talk about time and space complexity. Sorting the events takes O and log n time, where n is the number of events. In the simulation, each event is pushed and popped from the heap at most once, and each heap operation takes O log n time. Thus, the total time complexity is O n log n. For space complexity, the heap may store up to n events in the worst case. So, the space complexity is also O(n). Here are some key insights from this problem. This problem is a perfect example of combining sorting with a greedy heap-based strategy. By always picking the event that ends earliest, we keep our options open for future events. This is a common greedy technique for scheduling problems. The heap dynamically tracks active events, and the sorting step ensures we process them in the correct order. You'll see this technique not just here, but in many real-world problems like meeting room scheduling, task assignments, CPU scheduling, and more. Also, skipping empty days using the heap condition makes the solution efficient, without wasting time simulating unnecessary days. And that wraps up today's in-depth problem explanation here on BugNoJutsu. I hope this video helped you not just solve the problem, but also really understand the underlying logic behind greedy scheduling problems. If you found this helpful, make sure to like, subscribe to BugNoJutsu, and share this video with your fellow coders. Let me know in the comments if you'd like more detailed breakdowns like this, and I'll see you in the next video. Until then, keep learning, keep coding. See you soon.